Hello, everyone. I'm Steve Mcghee, and this is going to be a discussion about SRE and platforms and reliability and things like that. But first off, if you're just kind of getting started with all this stuff, we have a little website called conversations.dora.dev. You can go there at any time and just get a bunch of questions like this to kind of get people thinking about these types of questions. They drive good conversations. So I highly recommend just checking it out sometime when you have some spare time with your team or on your own. So this is me. I'm a reliability advocate at Google. I kind of made that title up. I was an SRE for a long time. I started at Google 20 years ago. I did SRE stuff for pretty much that whole time. I did leave for a while. I was a customer here in California at a company that wanted to move from the cloud or from on-prem to the cloud, and I helped them do that and try to adopt some reliability practices as well. So first off, the question that might be on people's minds, or at least the question that I like to put on people's minds is, can you do this? Is it possible to build more reliable stuff out of less reliable stuff? Seems like a weird question, but what's most important about this question is that every time I ask it, I get different answers from the crowd. I get half and half approximately. It's never all one way or the other. And that's what I really love about this question. My answer is yes. Yes, you can. And so don't forget about RAID, the thing with the disks. So you can have something like a SAN, which is highly reliable, built out of disks, which are not highly reliable. This may seem trivial, but it just kind of gets the point across of you can build systems that are more reliable than their component parts. It requires a few things. It requires some extra complexity, of course. It also requires that the components don't fail all at the same time. So we call these failure domains. And we'll get into what that means in cloud, but that's the basic idea. This is another model to think about. I call this the pyramids of reliability. Essentially, it used to be the case, given kind of the base model of, a service needs to be so reliable, so all its dependencies need to be more reliable than that, and the infrastructure needs to be more reliable than that, and the power and the water and cooling needs to be even more reliable than that. And this worked great. It worked for a long time. It also is a common, easy to understand mental model. It's the way things like gravity and buildings and pyramids work. It just makes sense. However, cloud is different. Cloud is like this. So cloud is, it's not exactly like this, but you get the idea. Cloud is kind of upside down. This is the idea where you're building these systems of more reliable systems out of less reliable component parts. But there are several of them, like I talked about. There's these failure domains. What does this really mean? Like, think about who runs the infrastructure and who runs the app, right? That's dev and IT or prod or cloud teams or whatever you want to call it. This kind of flips the script a little bit. That means there's more work to be done by the dev teams. Like, there's more coding in the app to be done when it comes to reliability. And there's actually less work to be done by the IT teams. Once you kind of set up the cloud stuff, that's kind of it. There's not that many knobs. It's not like you have to go in and like change the disks and replug in the wires. Like, that's gone. It's just an API now. I'm not saying there's less work. It's not saying that there's like a trivial amount of work in the IT and cloud space. There's plenty. But in terms of reliability of an application, a lot more control goes into the hands of the devs. So the problem with this is, if you're thinking on the left side here, but you're actually living on the right side, you're going to be in trouble. If you're all on the left side, that's fine, right? That's the traditional model. Really, if you want to build stuff in a scalable way, though, you want to be all the way on the right side. So you want to build stuff in cloud, but you also want to think about it on the right side. So one way to kind of prove my point a little bit is try to get a VM from any cloud provider that has 5 nines. You can't do it. All the VMs themselves individually, there aren't highly available VMs in that sense. There are sometimes they have product code that, but that's different. Okay. This also results in something you may have seen a bunch, which is when we move the old thing over to the new place, it doesn't work. And that's because we're trying to take a system that was built for previous expectations and put it in the place where more work needs to be done in the app layer than in the infrastructure layer, and it all falls apart. So we like to say that infrastructure changes can't fix the app, even though they used to. It's a bummer, but it's true. Okay. So what changed? Like, why is this new? Was it been like this the whole time? Really, it's because of these things called distributed systems, which are relatively new. They've been in academia for like 40 years, but they've been in like production in like this type of available commercially for about 20 years. 10, 20 years, right? So this is basically what cloud is. One way of thinking about distributed systems is that they're capable of being always slightly broken, right? They can continue to persist. They can continue to run when they are slightly degraded. That's the whole point, actually. Also, what's going on here is that we now have what we call warehouse scale computing, which is a lot of computers in one place or in many places potentially. We also have global audiences, and really consumers just have higher expectations of things always being on. So, visiting a website and seeing, oh, we're in the middle of a downtime maintenance period. People don't like that anymore. They're kind of less forgiving of that than they used to be. So we have to kind of change the way we're working. Expectations have changed. Here's Ryan Reynolds saying the thing. Okay. So there's this thing called SRE that developed inside of Google. The real reason for it is to scale operations. So if we had a bunch of traffic go up, like our business was growing when Google was new, and we had to linearly relate the operations team to the size of the business, we would get a lot of operators, and it would be very expensive, and it would be a problem. So what we did instead is SRE was developed so that we could essentially have this thing called sublinear scaling, right? That means that we can have, we don't have to match, every 10x growth of the platform with 10x as many operators. Instead, we use things like automation, standardized tooling, et cetera, et cetera. This is really the kind of the consequence of developing SRE. I believe it was also kind of the intent, but this is kind of the way you should think about it. There's a thing called SLOs. It's kind of a core thing within SRE. This is just a single slide on it. You've probably heard of it a bunch. One important thing is that an SLO, technically an SLI, is always a ratio of two things. It's not just annual metric. It's always a ratio of good stuff divided by the total of that stuff, measured over time. If there's too much of the non-good, right? If the nines are too low, we want to tell somebody or do something. So the SLI is the line itself that moves up and down, and the SLO is like the dotted line, which is like the goal. It's the objective. And then so during the time that we're under that, we call this you're exceeding SLO. And you don't want to exceed your SLO for too long. It means that you're kind of breaking promises, and no one wants to do that. Okay. There's a bunch of different types of SLIs. The most common ones are availability and latency, but there's more here as well. So if you have something like a pipeline, or you have like a reporting system, you don't really care about, the availability and latency if it has to run, every Friday or like once a quarter or something like that. But you might care more about like its correctness or its freshness, things like that. So there's a bunch of different things you could possibly measure. Okay. Things to think about in cloud. So we have these things called zones and regions. These are called the failure domains. They're like abstract failure domains within cloud. They're kind of the generic ones. You'll get them across pretty much every cloud vendor. The way to think about it is that as a zone, give or take, which product you're using, has 3 nines. A single region, which has many zones in it, is generally 4 nines. And then multiple regions, if you put them all together and use them all, carefully, you can get 5 nines. And that's kind of a rule of thumb. You can think of this when you're designing your systems. However, there's something to consider when designing systems that are made of many parts, and that is the more reliable it gets, the harder it is to run. And it does so. This is actually, I wish I could draw a proper exponential curve. This is just part of a circle. But an exponential curve here is what we're supposed to be showing, which is that every additional 9 that you add costs 10 times as much as the last one. So if you want 100% availability, that will cost you infinite dollars. You can pay at the window. Just kidding. So you probably don't want that. So when you see something like this, you say, "Oh, great, let's use the bottom one. That looks good." Remember, it's going to cost two zeros more than the first one, right? It's going to cost 100 times more than the first one, approximately. Again, rule of thumb. Okay. So think about those failure domains. Know about these abstractions, these concept of failure domains. What you don't want to happen is coordinated failure or cascading failure, right? We don't want to change multiple failure domains at the same time. That's coordinated failure or potential for coordinated failure. And we don't want it when one fails, that failure can spread to another one. That's cascading failure, right? So we want to contain isolated systems, right? So that if one fails, it stays failed in that one place. It doesn't spread. It's like a contagion. And the way that we do this is we talk about this thing called gradual change. We want things to fail in a contained place, right? We want to just change a little bit and have that change. If it was bad by accident, it just breaks one little thing that we can keep track of. Okay. Other things you can think about, make sure you have exit paths for these failure domains. So like if that domain, or I should say when that domain does fail, you can, as I like to joke around, you can run from your problems, right? You can just do something real quick to account for that. So if you think about this generically, which we've done inside of SRE for a long time, you can come up with a few kind of common scenarios. The first one that I like to point out is drain, which is simply stop sending traffic to that one failure domain that is unhappy and just let the rest of them continue, right? So the traffic that was going to that, that data center or that cluster or that zone or whatever, we say that old traffic that was affected will now spill to one of the other, or maybe potentially more of the other sort of surviving failure domains. There's a bunch of other of these things. We call them generic mitigations. There's a link at the bottom. Rolling back bad releases, doing freezes, blah, blah, blah. They're all on that site. They're pretty great. So if you can do these things, if you can do these mitigations, you're in good shape. Like this is the way that Google stays up so much, is that people can do this inside of Google. How do they do it? Well, they have to know about these to begin with. Then they have to build them into the thing that runs in production. We call that thing a platform, and we'll get into that in a minute. So you want to kind of consider these things, these failure domains, these generic mitigations when you're designing your platform. And like I said, we'll get to that pretty soon. This is another diagram you may have seen. This is called Dickerson's Pyramid. This is all the stuff that SRE kind of thinks about. And you kind of have to start at the bottom. This is based on Maslow's pyramid of needs. Like you don't want to do root cause analysis and incident response if you don't have monitoring, right? You got to start with some monitoring to get started. But these are all great places to think about if you haven't already. This is all in the SRE book, by the way. Okay. This is another way of looking at the same ideas. So these are the kind of the top principles of SRE. Accepting risk, like you're not going to have a 100% system. We kind of already covered that. You want to measure customer happiness. That's the SLOs we kind of alluded to very quickly. I know I'm going very fast here. That's fine. We want to apply gradual change. We talked about that as well, right? If you can start with those, you're doing really well. And then the last one is learning from incidents. Really, what are you learning about? You're learning about your system. It turns out when you have incidents, that's just the way of, the system nature telling you that you don't actually understand your system as well as you thought you did. So the best thing you can do is learn from it. Learn what it was that you misunderstood, and move forward from there. Okay, if you're really getting started, okay, I'll give you like a list of things to do. Start with SLOs, work on retrospectives, do reviews of those retrospectives and learn from them. You can do risk assessment and prioritization. So what is it you're going to work on? Like, what are you going to add to your system? Maybe you want to start adding some of these generic mitigations to your system. Maybe you want to add the concept of failure domains. Maybe you just need another failure domain. Maybe you need to work on being multi-zonal or multi-regional. And really, number 5 is just do it. Like start, right? Start doing something. Don't spend too long thinking about it and planning it and coming up with like a 10-year roadmap. Just get to work. That's my biggest number 1 suggestion, is just start working on something. Okay, so the question is, once you've started working on something, is it working? Like, are we getting better? So this comes from a program we have called DORA. You can see here, there's the logo. We have these 4 metrics that you can measure, and you can tell if your speed of delivery, your code is getting out there, your ideas are getting into production, and you can tell if they're staying in production, right? We call this stability. Is it sticking? Is it working? Is the system working as intended? You can measure all 4 of these numbers. As long as the measures are like getting better over time, you're doing good. Like, try not to compare yourself to other teams that are like wildly different from you. So if you have like a cool hip Node team and then compare them to like the Fortran mainframe team, I think we know who's probably going to win here, but like that doesn't mean that they're not getting better, right? You want to really kind of look at the delta here to make sure everyone's improving over time. Okay, but we're talking about reliability, so we're going to focus on the stability stuff. Really, at the end of the day, you want to measure yourself, right? You want to determine what's holding you back. You want to choose some capability, like something that you can do to your system. You're either going to build it or you're going to buy it, and then you're going to enable it. in something. We're going to call that something the platform, right? You're going to make sure people can use that new capability. You're going to get feedback from people like, do they like it? Does it work, right? And then you're going to measure again, did it help, right? You're going to measure those same 4 DORA metrics. And this is just going to last forever, right? So you're going to be able to figure out if the way that you're improving your platform is actually helping everyone deliver software better and keep it reliable on the system. And if you do like that, you're going to be in good shape, right? Try not to just guess what you think is going to work. Follow the infinity symbol. Okay, so platform engineering is that thing that we do in order to get stuff into the cloud, right? So we have an idea in our software developer's head, and the platform engineer provides this thing called an IDP. This is the internal developer platform. It is also just made of software, it turns out. The developer can access the platform through like a UI or scripts or maybe some other API or something like that. And it does this thing called, it follows these things called golden paths, which are really kind of like, best practices, whether that comes from the cloud provider or from like a regulator or just your company's own policy. Like, what is it that we want production to look like? How do we want people to actually push things? How do we want people to not do things, right? So these are things that we also, sometimes we call them guardrails, things like that, right? But they're encoded into the software. They're encoded into this platform. Makes sense. Turns out you've probably been doing this already, but we're just trying to define it a little bit more strictly these days. So we're calling it platform engineering. So if we're building a service, so we have our app developer here, and he built something that is called online store, and it has a front end. It's running on VMs, and it has some disks and load balancers, and he has another service called catalog. It's all part of one application called the online store. Okay, great. That's kind of managed through or built on or deployed through something called a platform. And that has, the tools for development, for build, test, and deploy, running, and then, just overall application management. So this is the thing we're going to talk about today, is that green bit. So let's just focus in on that. It can have a bunch of components, right? So the developer might be using Cloud Code. It might be some IDEs, a whole bunch of stuff with that. You can choose all sorts of products. These are all GCP products today. You can actually switch them out for whatever you've already got, right? Maybe you want to use something like Datadog, right? And you want to use VMware on-prem for some of your on-prem workloads because, you got the machine sitting there. You don't want to just waste them. So the point, though, is not which products you're choosing here. It's that they fit into this coherent picture of a platform. So this whole thing together is the platform. So at the end of the day, you've kind of got 2 products here, right? You've got an internal product, which is a platform, and you've got your external product, which are your applications. Maybe you have probably many of those blue things, right? The customers of the internal product are the developers for the application. So your platform's customers are the developers for the applications. They are your customers, so you should talk with them. The same way that product managers talk to end customers for your applications, internal product managers for this product should also talk to their customers. This was that infinity symbol that we looked at earlier. We want to make sure that your customers are happy, that the metrics are going the right way, etc. Also, that platform is made up of parts. Some of those parts might not always be working all the time, and that's fine, right? We can allow the platform itself to also not be 100%. It's important that we keep track of this, though. We want to be able to measure the platform itself just like it's an application. So this is a common pattern here. Maybe you have some parts of your application that have to be highly available, like the runtime of the app itself, like the nodes that are running the code. And sometimes the things can be less available, like maybe the CI/CD system. If it's down at night, maybe who cares? It's up to you. So I want you to separate these things, right? So think of critical capabilities, right? You can think about maybe you can have some systems that allow manual failover, right? CI/CD is a good example. Maybe you can say, well, it's not there yet, but we'll get to it later. Slowly over time, you can make your platform more and more reliable, but it's always a trade-off. So just having this in mind is important. Okay, we have these kind of ways of thinking about I call it the footprint of your app. So where is your app being deployed? Your platform should kind of expose this to your developers. They should be able to choose which footprint they're using. We would call these app archetypes in some of our documentation. So if you see this app archetypes thing, it comes from a paper. There's a bunch of documentation on the cloud website, Google Cloud website. You can learn more and more about them. I'm going to show a couple of them. I'll show one in detail, and I'll show you the rest kind of zoomed out. So like the first one is just good old hot cold, right? So we have active and passive zones. So we have our app deployed once in one zone and once in another zone, and only one of them is really on. So traffic only really goes to one. And if something goes bad in A, we fail over to C. And depending on the technology, maybe it's a DNS change, maybe it's a load balancer change, maybe we have to change the database, failover mechanism, blah, blah, blah. But essentially, just by doing this, we get a whole bunch of failability improvements, and everybody knows about this. This is super common. This has been going on for 50 plus years. This is just how you do it in cloud, right? So this is great. If you want to start somewhere, start with this, right? If you're developing a platform, you want to allow your developers a way to do this, right? Like if they want to just elect, I want my system to be slightly more reliable than just the base level, give them this option, right? Allow them a way to do this. Here's how you would do it with Google Cloud products, right? You might use GKE in 2 different zones, and then you might use like 2 different Cloud SQLs that are replicating to each other. These are the rest of them, right? These are a few samples. There's actually more than this, but this is kind of the highlights. So you can go multi-zonal. You can have active and passive zones. Active and passive regions. You can isolate those 2 regions, and then you can have like the global model, which is kind of like how Google runs its own consumer level systems. This is how you would deploy them. So if you had a mixed bag of services, some were global, some were multi-zonal, and some were active passive, you can actually deploy them all on the same set of infrastructure, as long as you have, in this case, 6 different failure domains. And so we have 3 zones in one region, 3 zones in another region, and you can elect just on how your CI/CD systems, how you're going to deploy your services, right? How you're going to mix and match these to build your apps to provide them different levels of availability. And this should be an elective choice, right? Your developer should be able to kind of just push a button or change something in a YAML file somewhere or whatever to be able to choose, I want to be all the way on the right or all the way on the left or somewhere in the middle. This is a very high level idea, but I think it gets the point across. Okay, again, don't forget, right? Like the more reliability, the more expensive it is. It's not just dollars, it's also effort, right? So to get all these things on the far left to talk to each other effectively and to get it all set up takes some doing. So just be advised, you don't want to put everything in the global or the multi-regional archetype generally, because it adds up. Okay, but the point of this diagram is you don't want to provide the infinite set of possible choices, give every developer every knob. You want to just give them, in this case, like 5 knobs. Say like, just pick one of these points along this continuous curve. So we say what we're doing is we're discretizing a continuous curve, right? And so that way they can choose, I want the one on the top right because this thing makes all the money. Or I want to pick the one in the middle, or this one's not that important. The bottom left one's fine. What's important here is that the further you travel along this thing, the bigger the E gets, the effort or the cost, and the smaller the R gets, right? The reliability gains are actually minimizing over time. And this is because of that exponential curve that we talked about. So we actually have a sample implementation here. So this is the thing that we're working on still. It's called Reliable App Platforms. We're doing this all in public. This is all on GitHub. You can clone, fork, contribute. We have issues, we have discussions, all these things. This is what we call like an MVP of a platform. So you can get started with this. It has basic CI/CD. It's got multi-cluster. It's got observability, and it's still going. So we're still working on it. Please come help out, check it out, fork it, and run away if you want. You can do whatever you want. It's great. So essentially, like this is kind of the goal I'm trying to get with this very quick, fast talking video. Is I wanted to get you with the hook at the beginning, all right? The can you build more reliable things on less reliable things? I gave you a lecture, which is all the theory that I just hand waved through. Now I'm giving you a lab, right? I'm giving you you can build an MVP of a platform today, right? You can clone that repo, you can run the setup scripts, and you can have your own running platform. It might not be exactly like what you run in production, but it gives you a place to mess around with stuff. Once you're happy with how this thing works, and maybe you've tried draining something, or maybe you have the idea of deploying something in dual region versus dual zone, and you've played with it in the lab, then you can move it to production. So it's really hard to move from the lecture straight into production without playing around with something. So what we're hoping to do is, by giving you this laboratory environment, you should be able to play with something that's real and see how it works. You can see how the code works. It's all open source, right? You can look at the YAMLs. You can look at all the Terraform that we're using. I bet it even has a bug or two that you could find. So please let us know. So If this works for you, please tell us. We'd love to hear feedback. So yeah, we started with these pyramid things. This whole talk has been a lecture. We're giving you a lab. It's called RAP, a Reliable App Platform. And so when you do want to move it into production, don't forget about DORA and don't forget about platform engineering, right? Measure that the things you're doing are actually making an impact on your team, right? And do it by engineering a platform, right? Do computer science, right? You want to build a product, an internal product, and make sure that everyone who uses it gains the value from it. That's it. That's my whole talk. I hope that was on time. I did it really quick. And yeah, that's it. I hope there's questions. All right. Thank you.